Hello, I'm building an ultrasonic sensor as a demonstration for the sonar capability on the Europa Submersible Explorer. So now on the receiving end of things, we're going to have a 40 kHz signal interacting with the PZT disk, which will induce a weak electrical signal. Now this signal passes through the rectifier, where it gets converted from AC to pulsating DC. Then that rectified signal gets passed to the amplifier, which will increase its signal strength. Then after that, we want to filter out any noise and smooth out this signal. So for my rectifier, I'm using a precision rectifier because that is useful for small amplitude signals, unlike conventional rectifiers, which are limited by the typical 0.3 to 0.7 voltage drop off across its diodes. Now I was able to determine that the output voltage is going to be negative of the input voltage if the input voltage is positive, and it's going to be zero if the input voltage is negative, right? So there's two problems with this. One, it's inverted because it's an inverted precision half-wave rectifier, and two, we have this zero over here. It's better that we have a full wave rectifier for this rectification into a DC pulsating signal. So what I could do to invert it, I could just plug in another op amp over here, an inverting op amp, and I can invert the signal, but we're still left with a half wave rectified signal. And so what we're going to do about that is turn this into a full wave precision rectifier as shown below over here. Now how this works is that it will be the exact same thing. We'll have our exact same original voltage output here at this V1. However, we're going to have a bypass of the original input voltage signal. With this, we're going to use an op amp as an adder. So we're going to add twice this output voltage to the negative of this input voltage. If we do the math on that, we will always obtain an output signal of V in, which is exactly what we want for full wave rectification. And I should specify that I mean the magnitude of V in. So over here I built a test setup for the ultrasonic transmitter. In this setup I have the transmit module, which I created by soldering two wires to opposite sides of a PZT disc. There's an off-the-shelf ultrasonic receiving module, which I'm using to validate the results or the signal of the transmitter. There's the Arduino, which is being used as a programmable microcontroller. And there's an LCD display to view the results in real time, instead of having to look into the Arduino's serial monitor. When powered on in this configuration, we observe that it is picking up on an object at 4.4 centimeters away. In this case, in the physical setup, the deck of cards is placed just under 5 centimeters away from the sensor. Thank you for watching.